Okay, so in lesson 5-6, we were doing the quadratic formula. So once again, the quadratic formula looks like this. Oops. If we have this function, ax squared plus bx plus c, then the quadratic formula is going to tell us how to find the zeros for that function or the roots for an equation. One thing you need to remember is that by separating it like I do here, you need to make sure that you have your fraction bar here under the radical, goes all the way across. You can't divide what's under the radical by 2 times a. So when you're solving problems with this, you need to first of all identify the values of a, b, and c. Now this will work for any of them. Anytime I ask you to solve a quadratic equation or find the zeros for a quadratic function, you can always use the quadratic formula. You know, if you can't figure it out by factoring, you can't do completing the square, you can't find anything by a table or graph, you can use the quadratic formula. So with this problem, number 24 here, a is 2, b is -5, and c is 3. So then we just plug those numbers in for those letters. Make sure that when you're doing the b squared, if b is negative, make sure you square the negative. One of the biggest mistakes people make is not squaring that negative. So there's 2 major ones. One is not squaring that, and also by trying to divide what's under the radical by that denominator. But that fraction bar is outside, so you have to simplify first. So here we have 2 negatives, so we have positive 5/4. Under the radical, we have 5 squared is 25, and minus 24, right? What's 25 minus 24? 1. Oh, that works out nice. What's the square root of 1? Okay, so here we have 5/4 plus 1/4 and 5/4 minus 1/4. So in this situation then, we are actually going to add this other fraction and subtract it. So 5 plus 1/4 will give me 6/4, and 5 minus 1/4 will give me 4/4. So we have 3/2 and 1 for our answer. Is there a way to check this? What's that? Yeah, we could plug it back in and see if it works. We could use our calculator then. We could put it in our y equals. So we've got y equals 2x squared minus 5x plus 3. And graph it. So these zeros are pretty close together, aren't they? If they're 3/2 or 1.5 and 1, they're pretty close together. So let me zoom in a little bit here. Let's go zoom 4 and see what happens. Okay, I can see there's 2 of them there. But if I hit trace, type in 1 and hit enter, I should have 0. And if I type in 3/2 and press enter, I should also have 0. Okay. So that's a way you can check to make sure you've got them correct also. Go back and use your calculator. Okay. So there's the quadratic formula. Okay, so lesson 5.7 was working with quadratic inequalities. And we did two things with those quadratic inequalities. One was graph them, which meant we had to do some shading. And the second thing we did was actually solving the inequalities, where we actually found a solution set that would be on a number line. Okay? So if we want to graph this, then we'll take out and get a graph out here. So we want to put this on our graph. So we can do a couple things with this. If you wanted, you could put it in your y equals, or you could look to see if there are zeros, but we do need to have an accurate graph. All right, so let's go ahead and, so for an accurate graph, we need to know what the y-intercept is, and we need to know what the vertex is to be able to help us to graph it. So we could use our calculator to find the vertex. So we put it in, oops. Negative x squared. Is that going to go up or down? Down. Okay, down because it's negative, plus 6x. And zoom 6. Okay. All right, so we need to find the vertex to draw the graph of this. So let's see. It looks like it's at 1, 2, looks like 3, right? So if I type in 3 and hit enter, all right, so I have the point 39 is where my vertex is. And so I need to make my graph so that I can do the point 39. All right, there we go. So I'll plot that point. All right, that'll help me with the graph. So the other thing is, once I know the vertex, I want to know the y-intercept to be able to graph it. What's the y-intercept for this? Okay, there is no constant, right? So that means it's 0. So I'll put a dot at 0 and a dot over here at positive 6. Why did I put one at 6, 0? Okay, because the graph is symmetric. So if it from on the zeros, if it's over 3 from the axis of symmetry, okay, then it would be 3 the other way from the axis of symmetry.
Please excuse this interruption. It is time to release the varsity softball team at this time. Thank you.
Okay. So when I graph this, then, am I going to use a solid line or a dotted line? Okay, it just says greater than, so that means it's going to be a dotted line. So you need to make sure you use a dotted line. Okay. So when I graph it, okay, make sure my line is dotted. And then the shade. Now it says greater than. Greater than always means above. Okay? So is above outside of the graph or in the middle of the graph? Okay, all right. The above would be outside the graph. So I'm going to shade in there. Let's see. So I'll shade out here. Now, is there a way I can check to make sure that's correct? Okay, we can check a point, right? Unfortunately, in this case, we can't use the origin because that's on our graph. So we need to check another point. So let's check the point 0, 1, because it looks like that's not. So if it's true, then shading on the outside is correct, right? So if I put 1 in for y and 0 in for x, is it a true statement? So is 1 greater than 0? Okay, and that's true, right? All right, so I shaded the correct portion of the graph then. So you can use your calculator to graph it. Okay? To make sure you have an accurate graph, just make sure that If it's just less than or greater than, that you make it a dotted line. If it's less than or equal to or greater than or equal to, you use a solid line. Right. Now, solving inequalities then. Right. When we do this, we're going to write our answer in 3 different ways. Okay. You're going to use it as a compound inequality, and we'll show that answer. You're going to put your answer on a number line, and you need to do it in interval notation. So using either brackets or parentheses, whichever one is appropriate. So to solve this algebraically, I want to be able to factor if I can. If I can't factor, I'll use the quadratic formula if necessary. But I'm going to set it up as if it's equal to, first of all, so x squared plus 4x minus 7 equals 0, or equals 5, excuse me. And I want to find the zeros so that when I go to my number line, I can graph the zeros on the number line and then use that to determine whether I'm going to graph between those zeros or outside of them. All right, so we'll subtract 5 from both sides. So we get x squared plus 4x minus 12 equals 0. All right, can we factor this? What are the factors of negative 12 that give me positive 4? Okay, negative 2 and positive 6. So we've got x plus 6 and x minus 2 equals 0. So the zeros then are at negative 6 and positive 2. Okay. Now we're going to use those zeros on the number line to determine what my inequalities are. So when I do my number line, all I need is, so I need to start at negative 7. So I need to make sure that I go one below and one above the numbers I have. So I need to go from negative 7 to positive 3. Okay. Now, on the number line, are we using solid dots or open dots? Okay. Same thing as the graph above. It's greater than or equal to, because the equal to, that means it includes the point. So I'm going to use solid dots on 2 and negative 6. So my graph has the 2 things that can happen. Either it goes out both directions, or it's going to connect them. Okay? Those are the options. How do I know which one it is? Mr. Hart, what do I do? Okay, plug what in? Okay, plug, well, not the zeros, because they're just going to give me a true statement. Okay, we want to do either something on the outside of them or something between them. Well, what's our favorite number? 0. So we're going to check 0 and see if it works. Right. Does this work? If it's true, then I'll be between them. If it's false, I'll be on the outside of them. So we put 0 in here. We go back to the original. So is negative 7 greater than or equal to 5? No. Okay, that's false. All right. So it doesn't work between them. So then my answer will be, okay, yeah. So it's going to go here and out here. Okay. So there's my answer on the number line. Okay. So if I read this number, how do I read this? No, just this part right here. How do you read just this part right here? X is less than or equal to 6, right? Okay. So we say x is less than or equal to negative 6. Okay. If there's a gap here, then we do what? Or. Okay, and it was great or, wasn't it? Okay, all right, and then how do I say this part here? Okay, so or x is greater than or equal to 2. Okay, so here's our number line. Here's our compound inequality. Then as a interval notation. So interval notation, this is going to where? Negative infinity, right? Okay. So then we have negative infinity to negative 6. Right? Negative infinity is not an exact number, so I use parenthesis. Or positive 2 to infinity. Okay, in lesson 8 then we looked at the finding a quadratic model that fits a set of data, or first of all, checking to see if a set of data even is a quadratic model. So if we look at number 8, how do I know whether this represents a quadratic or not? How do I know? Okay, if the second differences are the same. Now sometimes you can look at them and just see that yes, whether they are not. Okay. Now if I look at both 8 and 9 here, okay, for 8, all these numbers keep going down, don't they? Okay. So that could or couldn't, that's possible that could or probably not, or maybe not, okay, be a quadratic. Now look at number 9 though. Look at those numbers. They come down to 4 and then they go back up, don't they? Well, usually when things come down and go back up, that's a form of a quadratic, right? Because it's going to give you the nice U shape then, right? So let's check both of them. All right, so for number 8, we're checking to see if the x values are linear, first of all, okay? And then we're doing the differences. Okay, so the first difference is negative 7 minus 1, negative 8. 1 minus 7 is negative 6. 7 minus 11 is negative 4. And 11 minus 13 is negative 2. All right, so there's our first difference. Second difference. Okay, these all differ by negative 2. All right, so that tells me it is a quadratic, because the second differences are the same. No, we're not doing number 9. Okay, and we're just going to do, we'll do number 11 here. Okay. All right, they want us to write a quadratic function that fits these set of points. Okay. All right, to do that, we're going to put it in our y equals, or we're going to graph it to do it. Okay, use the calculator. So what do I do with the calculator to find the model that fits this? So first I'm going to go into my y equals and clear it. All right, go to stat, and then edit. All right, so clear your lists first of all. Stat and edit. Stat's right in the middle. All right, make sure your lists are clear. What goes in list 1? Okay, the x values go in list 1, so we're going to put 1, 2, and 4 in there. Okay. What about list 2? All right, the y values, so 3, 5, and 3. Okay, and they got to be in the same order, okay, to make sure those points match. All right, so what do I do then? Okay, all right, do we need to graph it? No, we don't have to graph it. We just need to find them. All right, so if we go stat, then over to calc, and quadratic regression is number 5. So we're doing quadratic regression. Okay. And then we don't need to put it into an equation or anything at this point in time. If you want to put it in an equation, you can. Right? Like if we could go alpha trace and put it in y1. and then we calculate it. And this gives us the values for A, B, and C, because we're going to have so this is going to be a quadratic equation where it looks like this. AX squared plus BX plus C. So here we get f of x equals, our value for A is -1, so negative x squared. B is 5 plus 5x, and C is -1. So negative x squared plus 5x minus 1 would be that equation then. Okay, working with complex numbers, which ones do you want me to go over for these? All right, which ones would you like to see done? All right, so one of the absolute value ones, so like number 16, okay? 16, all right. And what else, 23? All right, so okay. Any others? 25, all right, so one of the division ones. And so reminder that when you're adding or subtracting, like numbers 18 and 19, you're just adding and subtracting like terms, just like we did if there was an x there. Right? When you're multiplying, you multiply them just like you would if there was an x. The only difference is what? If we get I squared is equal to -1. So you have to change the sign of that part, all right, when you combine them. All right, so let's take a look at those. Okay. All right, so we want to find the absolute value. The absolute value of a complex number. All right, so absolute value of A plus BI is equal to the square root of A squared plus B squared. You're doing the Pythagorean theorem, basically.
Hi, is this director available for a second?
Yep. So, to find the absolute value, we do the square root of, what's the value of A in this case?
3.
3, so 3 squared. And the value of B is 4 squared. Okay. So 3 squared is 9, 4 squared is 16. So we get the square root of 25, which is 5. Okay. All right. So the absolute value is just doing the square root of A squared plus B squared. Number 23. Remember we did the pattern for the i's. Okay. We had I squared is -1, I cubed is -I, and I to the 4th is 1. Okay. So everything else applies to this. So what we want to do is we want to figure out, divide by 4, what's my remainder, okay, for the exponent, first of all. Okay. So if I take 15 and divide by 4, or if I do it this way, however you want to do it is fine. So if I do 4 into 15, what do I get? 3. Okay. I get 3 with a remainder of 3, right? Okay. So this remainder is the number I'm concerned with. Okay. So if I have a remainder of 3, that means that I'm looking at I cubed. Because this means I have I to the 15th is equal to I to the 12th times I cubed. In any power, any multiple of 4 is equal to 1. Okay? So this is equal to 1 times -I. Okay? I to the 12th is 1, I cubed is negative I. So this part here equals negative I. So that means I'm going to have 3 times negative I, which is negative 3I. Would be my answer. All right, so I raised to a power, multiple of 4, and what's left. Okay, and whatever's left is going to be either a 1, 2, or 3. And then, so our answer would either be I, negative 1, or negative I. Number 25 here. Now, we can't have I in the denominator. So that means we need to multiply by the conjugate of the denominator. What's the conjugate of 4 minus 2I? 4 plus 2I. Okay, the conjugate changes the imaginary part only, not the constant, not the real part. It changes the imaginary part. So I would multiply this by 4 plus 2I over 4 plus 2I. Because I have to multiply by 1. All right, I'm going to change the way it looks. I'm not changing the value of it. Okay? Anytime we reduce fractions, we're changing the way they look. We're not changing the value of them. Okay? All right, so the numerator, we FOIL. Get 12 plus 6I minus 4I, and then minus 2I squared. In the denominator, because we're multiplying by the conjugate, there's no middle term. And it's just going to be a number. 4 times 4 is 16. And negative 2I times 2I is negative 4I squared. Because if we did the middle terms, we'd get a positive 8 and a negative 8I, which is 0. So in the numerator, we have 12, and negative 2I squared is positive 2. All right, 12 plus 2 is 14. And 6 minus 4I is 2I. What's negative 4I squared equal to? Positive 4, right? Because this is negative 4 times negative 1 is positive 4, so I have 20 in the denominator. So we'll do 14 over 20 plus 2 over 20 I, and then simplify them. 7/10 over 1, plus 1/10 I. That would be the answer. All right, and if you remember the other day, I told you could do that in your calculator too, didn't I? Okay, take the numerator divided by the denominator. Don't put it in as a fraction. Numerator divided by the denominator. And then just change your answer to fractions.